Okay, welcome to this video on coding, and we're going to see how we might be able to simplify some of the numbers that we work with in our statistics work. Now, let's just have a look at a couple of data sets before we begin. I'd like to have a look at the red one and the green one. You can see that the green one is a bit more spread out, but both these data sets have the same mean. The green one would have a larger standard deviation because it's more spread out. And another couple, these two have both got exactly the same standard deviation. They're spread out in the same manner, but they don't have the same mean. The blue set has a higher mean than the red set. So just bear that in mind as we go through this video. And I'd like you to have a look at this data set, which we'll call X. And here's the numbers 110 and so on. And we're going to have a look at the mean to start with, and you can probably spot from a bit of symmetry that the mean of this data set X is 130. You could do the calculations to work that out and check, but the symmetry tells us the mean is 130. Now let's see if we can simplify these values slightly. The first thing we're going to do, and this is going to be coding number one, is we're going to subtract 100 from each value. And that's going to give us a new data set Y. So I'm just going to do 110, take away 100, is 10. 120, take away 100, and so on. So I'm going to get a new data set here. Now what's happened to the mean? The mean of the new data set is 30. So the mean has obeyed the coding, if you like. We take away 100 from the mean to get the mean of Y. Let's see if that works for a different type of coding. Another way we could simplify the numbers is maybe to divide them each by 10. That would give us 110 divided by 10, that's 11, and so on, 13, 14, 15. There's another way we could have worked out Y. Now what's the mean this time? Well, it's 13. And has that obeyed the coding? 130 divided by 10 is 13. So the mean is behaving itself in a way that's quite convenient as we simplify these numbers. And if we combine the division and the subtraction, we could work out a data set Y by subtracting all the values, 100 from all the values, and then divide by 10. And now we get 1, 2, 3, 4, 5. And the mean of this set is 3. And if we have a look at how that might be written down formally, our data set Y, 1, 2, 3, 4, 5. This is the coding that we've used. Take away 100, divide by 10. The mean, Y bar, we can substitute in, and the mean of X bar, we can substitute in. So we do X bar. Now X bar is this number here, the mean of X, that's 130. Take away 100, divide by 10. 130, take away 100, divide by 10, that is indeed 3. Now, according to this, if we code our data, we get some simpler numbers. We can work out the mean here, that's Y bar. We can use that to find X bar when the numbers are a bit more difficult. And we can do that by substituting in. So 10 times Y bar, which is 3, plus 100. And we're kind of reversing the coding here, and that gives us 130. So X bar equals 130. So simplifying the numbers, calculating the mean of the new set, and then rearranging the formula here, if you like, to reverse the coding to find X bar. We've made X bar the subject. We've got a new equation, we can substitute our numbers in, and it gets us back to the mean of the original data. Let's have a look at an example. This is an example of linear coding. The formulas here are linear, there's no squares or cubes or anything like that. We're just doing multiplication, division, addition, subtraction. That's linear coding. Here's an example. Use this coding, y equals x minus 7 divided by 80, to calculate the mean of this set of data. Okay, so we've got our x values. We can now calculate our y values. We put the x values into this formula. Take away 7, divide by 80. Let's see what we get. First one's going to be 10. And I'll just go through this quickly. 9, 2, 2.5, and 9.5. And if we calculate the mean of y, so y bar, we add up all the y values. That's 45 divided by how many there are, which is 6. 45 divided by 6 is 7.5. That's the mean of y. That's y bar. Now we can rearrange our coding formula to make x bar the subject, and if we plug in our y bar 7.5, make that the subject, we should get x bar equals 80 times y bar, which is this number here, 7.5 plus 7. And that comes to 607. And that's x bar. That is the mean of our x values. And you might want to just check that you're happy that the mean of x is actually 607. And you can see that we've worked that out with simpler numbers. We didn't have to add up all these x's. We just added up the y. So a little bit easier. Here's another example. This time from a group frequency table. Now you know how to find the mean from a group frequency table. Let's see how it works if we use a bit of coding. We've got our ages, we've got the frequencies, and when you're working out the mean from a group frequency table, you need a column for the midpoint. That's the midpoint of our ages. We'll call that x. So first value, we're looking for the midpoint from 11 to 21. So we can add those divided by 2, and that gives us 16. So we can fill in our midpoints. Now, here's the coding formula that we're going to use, and we're going to apply this to x, so the midpoints. So we're going to do y equals x minus 14 divided by 2. So the first one, 16, take away 14 divided by 2 is 1, and we apply that to each of the values, each of the x values, to get our y values. So we get 1, 5, 7.5, 10, 13. And then the final column, instead of doing f times x, this time we're going to do f times y. So f times y, so the first one is 11 times 1, and let's fill the rest of these in. And at the bottom here, we're going to add them all up, this column, so we're going to get the sum of fy, and adding those up we get 749.5. And the sum of the frequencies, we need these as well, add this column up, we get 100. And the mean from the group frequency table, this is an estimate of the mean because we haven't got all the exact ages of all the people in the survey, but this is our estimated mean. So sum of fy is 749.5 divided by sum of f divided by 100 equals 7.495. Now that's y bar, and we can find x bar, so the mean of our original data set, by rearranging the coding formula and substituting x for x bar and y for y bar and so on. So if we rearrange this, we get x equals 2y plus 14. So x bar equals 2 times y bar. That's 2 times 7.495 plus 14. And if we calculate that, we get 28.99. And that, we'll just check, that looks like a reasonable estimate for the mean age, 28.99. You'll spot that I haven't rounded any of the numbers at all, but if you want to round at the end to give your answer to three significant figures, 29.0. So there's an estimate of the mean using coding from a group frequency table. Now I'd like to have a look at standard deviation as well, and we're going to go back to our data set X, and first thing, I think you can have a go at this actually. Just pause the video, have a go at calculating the standard deviation of this set of data. Okay, hopefully you've all had a go at that. This is the formula that we will have used, and when we work out the sum of x squared, we get 85500. There's 5 pieces of data, and the mean is 130, and the standard deviation 14.1. That's 3 significant figures. So that's the standard deviation of our set of data. Now, I'm going to have a look at the codings that we used earlier when we were looking at the mean, and again you can have a go at these to practice using the standard deviation formula. If we code the values by subtracting 100, we get a new set of data y, and if we calculate the standard deviation here, again, as I said, just pause the video and work these out yourselves, but if you've done that, standard deviation of this set data is 14.1. If we code by dividing by 10, we're calculating the standard deviation here, and we're going to get, that comes to 1.41, and the third coding, standard deviation of this set of data, comes to 1.41. Okay, so how is this helpful to our calculations? Well, the standard deviation of our original data set, we'll remember, was 14.1. So what's happened? Well, if we take away 100, it hasn't affected the standard deviation at all. The standard deviation is the same. But if we divide by 10, we've divided the standard deviation by 10. And if we've combined the subtraction and the division, well, we've just divided by 10 for the standard deviation. So it seems that only the division has an impact on the standard deviation. Subtracting 100 has made no difference at all. And it turns out that that's fairly straightforward, because if you see from our set of data that we looked at earlier, if I just add 2 onto each piece of data, the standard deviation isn't affected. So the standard deviation is only affected by multiplication and division, and not by subtraction or addition. And that's a really useful thing. So here's what we can take away from here. If we use the coding y equals x minus a divided by b, then the standard deviation of y is the standard deviation of x divided by b. This minus a or plus a, whatever it is, makes no difference at all. And so if we're going to undo our coding, we can say that the standard deviation of x is b times the standard deviation of y. Here, just rearranging that. The subtraction makes no difference at all.